Hello everyone, this is Hassan Najafi from Akamsi Group. In this video, I want to show you how to create a mesh with block technique by using Ansys ICEM CFD software for a tube, for a cylindrical tube as an example of the geometry in this tutorial. So let's go do it. First, as you know, we need to create a working directory. I already made that, and set the working directory to the software by saving project in that working directory. Here just I mentioned project 1. It can be any name, so I save the file here. So the next step for creating the mesh is creating the geometry. Let's make a geometry. The geometry will be a cylindrical tube. For a start, we need to provide the dot in the ICM CFD, provide the point, I mean. But before that, we need to set the unit. So for setting the new unit, we go to setting, and here you can set the unit as a millimeter. I want to set unit as a millimeter and click OK. And here in the geometry tab, you can set the points. So you can set the points from the screen by setting or giving the X, Y, Z dimensions or any other parameters that I will show you some of them in this video. First, let's go to create the 0, 0, 0 point in the software, and when you click apply, you will see a dot here. Normally you should see the unit here, but let's say do it again, millimeter, apply, and OK. So here you can see the millimeter. The next step is to create the circle in the XY plane, but I want to create the circle by 3 points, so I need to specify the 3 point here. I just mentioned 10 millimeter for here. If you set a fit window, you can see the 2 points here. For your information, if you hold the middle button of your mouse, you can move the view from left to right, up and down. If you just scroll up and down your middle button, the middle scroll, you can zoom in and zoom out. And if you hold the right mouse, you can see it will be rotate, and if you hold the left button, you can see it's rotating in any direction. Okay, so we will go for creating the next point. X should be 0 and Y should be 10. So with these points, I'm gonna make a circle with diameter of 20 millimeter. So it will be around 1 centimeter. Excuse me, 2 centimeter. Okay, so here you go. We should have the same point here in the Z along the Z direction. Let's say we want to create a tube with the length of the 200 millimeter. It will be 20 centimeter. So we need to create these points. Let's say 10 and 0 in the 200 millimeter direction. If you click apply, the point is generated, and if you set fit window, you can see these two lines here. And if you hold the left button of your mouse, you can rotate the view. So we should have these other 2 points as well. So I select 10 for the Y direction and click apply. If you want to change the view, you can see here view, like you can set the view from any direction. You can set it from the front or back. So front, it means that it's X and Y. It's normal to the X and Y direction. So this is the points that we need. Let's go to create the circle first. So here we want to create a circle with 3 points. When you click on it, the software will ask you select the 3 location with left button. So we should use the 3 location. So we already created the points here. So we just using the left button to set the points. First, we need to start from the center point. Okay, here. Then the other 2 points. And when you did that, you will see the lines created automatically. Okay. And the action, I can say, or the command is still active. So you need to click on the right button of your mouse to deactivate the action or deactivate the creation of the circle. Here I forget to do it in the middle, so we need a point in the center of the circle in this side as well, which will be the outlet of the pipe. So I will click OK. So here another points. I create the circle, as you can see. In addition to these 2 circles, considering inlet and outlet, we need a line, a guide to make a surface. So I click here, and first this point and this point. Middle button to approve, because this mentioned here middle, it means done. Right click, it means cancel. So you can see here. The next step is to create a surface, because we already just have points and curves. And here on the left side, you can see in the parts tree, this just geometry, and in this part you can see the points and curves. So let's create the surface. I select this one. In order to create a simple surface, I will choose this one to just create a surface in the inlet and outlet. So I click on this one. But you know, when you want to click in a complex geometry, you may select a point or a surface instead of the curve. So here there is some options. Sometimes it's appear in the system, in the software. I will show you in another comment when it's appear. So when you select the curves, you click on the middle button, so in order to approve it, and right click to cancel. So you can see some lines here. This is the view of the surface, because we have wireframe. If you select or if you active solid, so let's show you how to active. Going to the surfaces and click solid. If you select solid, you will see a solid view of the surface. So let's make another one. I keep it as a wireframe. Let's make another surface for the outlet. I just click this one, middle, right click. And even if you click solid, you will see it's already generated. For another surface that we're gonna have it, we need a surface as a wall for this tube. We can make it with 2 methods. One method is just select these 2 curves, and another one select 1 curve and 1 direction, which I want to do it with this one. Or sweep surface you can also use, but this one is also possible to make the wall, surface for wall. So first it asks you to select a curve. with left button. Okay, I just click that one, and then it's asked the direction, the driven curves. So it is a straight curve. I select this one and click on the middle of the button, and here you go right click to cancel the action. So here you will see the surface is already created. So this is the tube, or we can say, yeah, you can say tube because it's almost 2 centimeter. The next step is to name these surfaces. We need to name these surfaces as well. So for selecting the name, because the name that we select here will be the boundary, the name of the boundary conditions in Ansys Fluent or CFX or any software that you want to use in the future. Let's say we want to have inlet. So I just rotate this, as you can see from here. Click on the right click on the parts and create parts. I just name it as a inlet. So for selecting the geometry, I click on this button here, and here you can see the options. For example, you want to select which one. At this point, I just want to select the surface. So I deactivated the other parameters here. Just I keep the surface active. So here I select the surface and right click, middle click to be done, and right click to cancel the action. So I will disable the inlet. You can see it's disabled. I also need to create a wall or assign a wall name here. As you can see, it's already, the surface is already activated. So here I select the wall and middle click to done, right click to cancel. Again for the outlet. Okay. So I deactivate the names here in order to see whatever left. So we can see the points and curves. The next step, I add the points and curves to the specific name. Like for inlet, add to part. Here I active the points and curves like this, middle to save, because I hidden the inlet geometry or inlet parameters. So when you assign the parameters to the inlet, they will disappear. For the outlet, add to part. As you can see here, middle to save the parameters, right click to disable it. So here you can see all the points and curves assigned to the outlet. So for the wall, same procedure, and it's done. When you did that, you can see the GEOM or the geometry name is not appear here again. It means that the all names is assigned to the specific name. All parameters like points, curves, and surface. So we are already done with the geometry, so just save project. Okay, the next step is to create the mesh. I already told you that I want to create the mesh with block technique, so we need to create a block for the mesh at the first step. I will go to the blocking tab and right click on the create block. Here by default it's the block name was solid. I will change it to the phalloid because I want to have a phalloid in the tube. So I click on the phalloid, and here you can set the type of the block. So because I have a 3D geometry, I select 3D bounding box and I click here. So here the software asks you to select the geometry. you can select manually, or you can click on this one, select all appropriate objects or all visible things, and then you will see a block is appear around the geometry. Right click to deactivate the creation of block action. So here you go, you will see a block. I disable the surfaces, and here the block. As you can see, a block is appear around the geometry. So the next step is to assign the points, assign the vertices to the points, assign the edge to the curve, so we can set the dimension to the edge. In the block technique, we have a block and the geometry. In this method, this black lines called edge, and the color one called curves. This I can say plus sign called as a vertex or vertices, many of them, and this blue point considered as a point. So you should realize the differences between the parameters in block and parameters in geometry. So in order to have a structure mesh using block technique, we need to associate. Yes, we need to associate the vertices to the points, the edge to the curve. To do that, first I need to have more points. In order to have more points, I will go to the geometry and click on the create points. As you can see here, we have many methods, but the methods that I want to use at this time is this one, parameter along a curve. So I click on the parameter along a curve. So here this means that this is a curve from, let's say, if this one the first point, let's say from 0 until to the 1%. So it will create points. I want to have a point here or here and here and here. So it will be 0.125%, I can say, or the distance out of 1 along the curve. So when I put this parameter, I select this one, and you will see a point here. I do it at here, the same things, without cancelling the comment. When I create the points, I right click to cancel, and I change the parameters to 0.375. So this value is very easy. We have 0.5 here, middle of it 0.25, and middle of it 0.125. So if you want to have another point here, you need to add 0.25 to the previous one, like so here we have a point, so it was 0.125. I will add 0.25, it will be 0.375. So I click here, you will see the point is created here. Same here. I will do the same procedure for the other points. 0.625, yes, and I click here and here. Another one, 0.875, here and here. So right click to cancel the action or function. Here you can see the points. So now if you view as a front, you can see all the points is in the same direction, line direction, which shows that everything is perfect at this time. The next step is to associate the vertices to the points. Just pay attention to that. This vertices is now a black. So I click on this one and click on association vertices, or associate vertex, yes. So I click on it. When you click on it, the software will ask you, because we want to, okay, this is one more thing. Because we select this one, it's already select point. If you select this one, it will be curve. Okay, so the software will ask you select vertices or vertex here. So I select this one first. The next step, it says select one point. So I select this one. If you want to done with this action, just middle button. Click on the middle button of your mouse. But if you want to continue, you don't do that. So I will do the same procedure here. Vertex, point. When you see this plus sign is changed, the color of it is changed from black to red. Pay attention to this. I select the vertex and point. So it means that this vertex is already associated. I will do the same here. You can see the color is changing. Right click to cancel. So here you can see I associate the vertex to the point. The next step is to associate the edge to the curves. I will do on the blocking tab, associate, and select associate edge. So in this section, I should select the edge at the first time in an order. Okay, then middle button to activate it, and then select the curve. You can see the color of the edge is changed from black to green. I will do the same process here. So we're done here. If you want to see the pattern of associated parameters, in the blocking tab you can click on right click on edge and show association. Here you can see the vectors. It means that this edge associated to the curves. I deactivate it. You also need to associate these four edge here to the curves, but since the geometry is very simple and it's aligned to the curves, so you don't need to do this at this time. But in complex geometry, maybe you have to do this. So here we did the associate action for the parameter of blocking, like edge, vertices, to the points and curves. Okay, here we have some geometry. You can also edit this one. Okay, it's gone. I just click on it, because if you select here, it's already assigned to the inlet and outlet. Okay. So the next step is to set the number of element to the edge. For doing this, you should click on pre-mesh params and select this one, edge params, and select this edge. But we don't want to do it for all edge, so there is an option here, copy parameters to our parallel edge. You can see all the parallel edge is now active, and then you can set the nodes. Because this is 200 and I want to have elements with 1 millimeter, so I put 201 nodes for this edge, and for this one as well I will put just 60, let's say. Even you can see here the spacing 1 and spacing 2, the value is around 1 millimeter. It means that we have 1 millimeter distance in this edge. So I click apply here and here 16, apply and OK. After you set the dimensions, you need to create active the pre-mesh here, and says yes. So here the pre-mesh, it's a pre-mesh, it's not a mesh that you can use for a solver. You need to right click on pre-mesh and show it as a solid and wireframe, and you need to disable the edge. So here the final pre-mesh that you can see. But as you can see here, this is not an appropriate mesh for a tube because it has many low quality, or I can say high aspect ratio. If we report the quality here, you pre-mesh quality, so select the quality from this section and click apply. You will see we have some elements with a quality less than 0.2. If you want to see them, you just click disable the pre-mesh, and here this is the lowest quality, or here. But this is not appropriate elements that we need, so you need to right click on this histogram and done. Let's improve the mesh. So this is not a good mesh for tube. What we need to do is to create the O-grid. In order to create the O-grid, we need to split the block. But for your information, there are many grid type. We have O-grid, C-grid. I will provide some information in our website Alcom.ca, and I put the link here for you in the description section, so you can go and see the differences between C-grid, O-grid, and how to make it. But here we need O-grid. It means that we need a OS block in the middle. How we can do it? So it's very easy. First, you need to, in order to see the block, you active the block, but it's in a wireframe. You can select as a solid here the block, and also you can disable it if you want. So we will go to the blocking tab, and in a split block, in this split block you can divide this block to the two sections, but I don't need to do it at this time. I just need to create the O-grid, so I click on the O-grid block here. For the O-grid block, the software will ask you select the block. So because I already assigned the block for viewing with solid, so you can see the block as a solid. Okay, I click the block here and click on the middle of the button, and we need to also select some faces. So because we want to have a O-grid block from inlet to outlet, we need to tell the software that we need the O-grid from inlet to outlet. Don't set the other faces as you can see here. If you want to see the result, you can check and practice, but at this point we don't need. I click on the middle of the button and then it's done. Another parameter that you need to set is the offset. This is the value between this between this point and this edge of the O-grid. Let's say I want to have 0.8 offset. From here to here, it's a 0.8 scale. If you want to less distance, you can set 0.2 or 3. You can practice later also. I will click apply and OK. Because it's already done, no need to OK. So here the O-grid block. If you set the view as a front, you can see it's perfect. So just click on the pre-mesh, and here the mesh. But there is another problem. We don't have any elements in this direction. So I again active the edges and going to the pre-mesh params. Okay, it's recording. Going to the pre-mesh params and select this one. I will select, let's say 15. 15 is too much, let's say 10. Okay, click apply and okay. Pre-mesh here. So in order to see the better mesh here, this is the best mesh that you can get. If you check the quality, you will see it's more than 0.7, which is so perfect. Okay, right click on it and done. So as you can see, this is the good mesh for your simulation. But imagine if you want to have a turbulent flow within the tube. So you want to use a turbulent model for in your simulation. Let's say if you want to use K epsilon turbulence model, you need to have a dense mesh here near to the wall. Okay, in order to have a dense mesh near to the wall, we need to have elements with very little amount of height. In order to do that, we need to set some adjustment here for this edge. In order to do, I just go to the pre-mesh params and select the edge. So because we already set apply to all parallel, it's apply to all parallel. So here we will have a mesh law. In order to select the mesh law, you just click on it, and let's say this one, big geometry. I want to show another one also. So here the spacing one. This spacing one means here you can pay attention to this arrow. This one will be a space 1 and this one a space 2. This is how the ICM CFD works. You select let's say 0.01 millimeter. I just give the number, but you should calculate this value considering the Reynolds number that you have and the Y plus that you need. If you want to K epsilon turbulence model using enhanced wall treatment method, so you need to have a Y plus around 1, less than 1. So you have you need to do some calculation to calculate this value. So I click on a space 1, 0.01 and click apply. Okay, I forget to set the ratio. Let's say 1.2. Apply and OK. So if you click on pre-mesh, you will see here we have a more denser mesh or elements, but here it comes to too much big. It means that we need to increase the number of elements to 20. Okay, so here the new mesh, but still it's not perfect. As you can see, there are big elements here. So we need to increase the number to 30 because this is a turbulence simulation or model. So you need to have dense elements there. So here you can see it's a perfect simulation, perfect mesh for your simulation. But imagine your turbulent flow is too high, and in order to see the boundary layer next to the wall, you need to have more dense mesh here. So one method is to increase the number of the elements, but another way to create the best boundary layer mesh is to change the method, the mesh law. You need to change it. We have exponential 1 here, so this one is very better. If you just click apply, you will see what's the differences. So it has more dense elements here, and if you just change the ratio here, you can see more dense mesh element. Another way or even you can reduce the number here, as you can see here. This is the new mesh. But another method that you can use is spline. In spline you can set the first element like 0.001 and hold the red dot here and bring it down, as you can see here. So this is a linear ratio. But if you have a spline like logarithm ratio, just click here with the left button of your mouse and hold the red one and take it like this. So here you can adjust the way you want, or even you can add more here. So here you can control the elements in your boundary layer. See, I click on done and OK. If you rename it, here you go. You can see there are more dense elements here, and you can do it again. If you select this one, it will be pop up like this one. Even you can set a space for the other direction, and here you go. I guess it is good things for turbulent model, good mesh for a turbulent model. And you can see how mesh is here with the first high for the element near to the wall. So at this time we're done with the mesh. You can just practice to provide a better mesh if you want to have it. Okay, after you finish the whole creation of the mesh with block technique, this is the pre-mesh. Actually, you didn't save the data in the working directory, and even you didn't save the mesh for the Ansys Fluent software. So just need to save project. I want to tell you what kind of file will be saved in the working directory. Here you can see the prj file, which is the project file. Here tin file, which is a geometry part. If someone asks you to just give me your geometry file, you can send it this file to them. And this is all the things that we have, and all setups for the block parameters. But still we don't have any mesh here. In order to do, we need to go to the file, blocking, and save unstructured mesh, because ICEM need an unstructured mesh in order to create the mesh file for your Ansys Fluent software. Let's say the mesh file with MSH file. But you know, don't confuse. It mentions save unstructured mesh, but we have a structure mesh here. What's the difference between them? We have a structure mesh, but in the coding feature of the software, it needs to have a unstructured mesh in order to create the appropriate mesh for the other software. So I just click save unstructured mesh. I can name it just the same name here and save. Here you can see the UNS, the file project1 with UNS name, USM type, UNS type. So this is the mesh, unstructured mesh. The next step is to go to output mesh and select your solver. Here I want to have this mesh in the Ansys Fluent, or any other software that you want to have it, you can select here. I said Ansys Fluent, so it's okay for me, and then click to the write input. After that, it asks you to save the project one more time, and the software will ask you, please give me the unstructured mesh. So I just give it to the software, and here the Ansys Fluent setup. It asks you the mesh is 3D or 2D. You should pay attention to this. It's a 3D. And do you want to do the scale here? If you want to do the scale here, yes. If no, so just active no. because we created the whole mesh or geometry in and started from 0, 0, 0 point, like that point, and if you scale the geometry, it won't affect your simulation. This is one of the good things, that if you want to have a CFD model, it's better to consider as a origin. Maybe you in the future you need to scale your mesh, so later you can do it. And here is ask you what name you need to select for the mesh for the Ansys Fluent. I just says it's project 1 and done. If you go to the working directory, you will see a project1.msh folder. If you want to see the extension, you need to go to the view, file name, extensions. Now deactive. See, it's PRJ, it's changed. For the MSH, it's already there. Okay, it's good. So now we created the mesh, the structure mesh, and we have a MSH file which I can use it in Ansys Fluent. Let's launch the Ansys Fluent and see if the MSH file is working. Here the Ansys Fluent, I just copy the working directory and paste here. As a dimension, I select 3D because it's a 3D. I can disable the double precision and select the serial as a number of the solver and click yes here. Here you go, the software is launched. The first step is to read the mesh file, project1.msh. okay. It will give you the whole details. When you see the mesh here, it means that everything is perfect and there is no problem here. So this is the mesh file, as you can see here. This is the mesh file, and if you want to report the quality, you can see it's even more than 0.7, 0.8, which is very good. And if you want to check the mesh, you can see there is no minimum negative value for the volume. This is very important step that you should do. But for your information, if you want to do the turbulence model and if you have high aspect ratio next to the wall, it would be better to activate the double precision in the launch menu, because you saw that I disable it. It's better to activate the double precision because it gives you more precision in your calculation. So here you can see the scale. So this is the 0 Z minimum and maximum, 0 to 200 millimeter, because I already created millimeter. So and the unit for the software is meter. That's how it's happened. So I can just change it to the millimeter, but still you can see it's getting double. So I return it back. The only things that you can do is mesh was created, do the scale. You can do the specific scale, like you can make it 2 times the dimension in the x direction, or you can convert units. Mesh was created in what? Millimeter. I already created the millimeter, so this is the scaling factor will automatically appear here, and just click scale here. And you can see the maximum of the z direction is 0.2, which means 20 centimeter. I just click close. You need to display it again, and here you go. This is the mesh, and this is the scale. You may confuse why in y minimum and maximum we don't have like 0.001. We have many numbers here. The reason is that if you just zoom into this, and if you remember, the 0 point was in the middle of the tube, and if you goes right, here is the x maximum. But why it's not 0.01 0 1. The reason is here, because if you pay attention to the mesh, in this location you can see a little deviation from the surface, from this point. That's what happened here. If you don't want to have it, which is not a big deal actually, you can do like this: increase the number of the mesh here. This is one of the methods. Instead of 16, you need to have 17. Okay. Now if you look at it, if you import, export this mesh file for your Fluent, you won't see this again. But if you saw this one, it's okay, it's not a big deal. Still your simulation will be valid. So that's it. And if you go to the boundary condition, you will see inlet. It's automatically consider velocity inlet. This is outlet. It's considered just outlet vent. You can says outflow or anything else. Pressure outlet, you can change it, and here is valve. And in the cell zone condition, you can see the fluid and type of it is fluid. Softwares can automatically detect these things. And you are ready to do the setup in Ansys Fluent. Okay, our tutorial is finished at this step. Thank you for watching this tutorial.